What I've done is I have combined the first two lessons in this chapter. The first lesson was solving one-step equations and the second was two-step equations, and I have a lot of faith in you guys. It's basically the same thing, so we are going to join those two together. So the learning target here is that I can solve one- and two-step equations. You should have this part here memorized by now. The ultimate goal of any equation, baby equation or crazy quadratic equation, is to isolate the variable, to get it on one side of the equal sign by itself. Isolating meaning make it all by itself on that side. And so the question is, I know what I need to do. How do I go about that? What you do is you undo what's happening to the variable using inverse operations. You undo that instead of before where it was just a plain expression and you did step 1, step 2, step 3, order of operations. Now we're going to undo whatever is being done to the variable. So addition and subtraction undo each other. Multiplication and division undo each other. And here's a new thing for you. Whoops, I misspelled there. Okay, much better. Powers and roots, like if I have something squared, I can undo that with a square root, or if I have something to the third power, I undo that with the cube root. We're not going to be looking at that just quite yet. That will come later though in the year. So the properties of equality, you can apply these to any operation. You could have the addition property of equality, subtraction property of equality, multiplication property of equality, division property of equality. But when you boil it down, what it means is that whatever you do to one side of the equation, meaning one side of the equal sign, equation has a left side and a right side. Whatever you do to one side, add, subtract, multiply, divide, you must do to the other side. You have to keep things equal. When you're doing the baby equations, kind of like what you're going to be doing today, it's going to seem tedious, but I promise these equations are going to get much crazier, and it is very important that you train yourself now with the easy equations so that it's second nature and you're not so overwhelmed by the bigger equations that will come. So let's take this equation. Negative 3.2k equals 14. So you ask yourself, what is happening to the variable? It's being multiplied. So since k is being multiplied by negative 3.2, use inverse operations to divide each side by negative 3.2 because of the division property of equality. So I know that I need to undo that, so I'm dividing here, which means I divide on the other side. And when you actually do that, let's see what you get. 14 divided by 3.2 is 4.375. So k equals, and it would be a negative because you have different signs, 4.375. Make that bigger so you can see it. There you go. So what about when there are two operations? That's going to be your two-step operation. Which one do you do first? So let's take this equation right here. T is being divided by 2, t over 2 minus 3, but it is also having 3 subtracted from it. So to know which one to do first, you undo the operations in reverse order of the order of operations. So we said we were undoing. So it makes sense that we would start at the bottom of order of operations. We're going to undo adding and subtracting first, then we're going to undo multiplying and dividing. So there is the order of undoing, if you would like to call it that, or SADMIP instead of PEMDAS. So here's our equation, t over 2 minus 3 equals 5. We're going to undo that subtraction. We're going to do that by adding 3 to both sides. Make sure you're showing that you're adding on both sides. Don't just do one side of it. You finish that out there. You have t over 2 equals 8 left because negative 3 and positive 3 cancel. 5 plus 3 is 8. And so what happened there is I simplified. And then I'm going to undo t being divided by 2 by multiplying both sides by 2. Cancels there. And what I'm left with is t equals 16. That's what we're left with. T equals 16. Now one of the beauties of equations is I can check my answer. I can put it back in there. So I'm thinking that t equals 16. So in my head I'm going to put 16 back into t. 16 divided by 2 is 8. And then 8 minus 3 is 5. And so since that equals out, I know without a shadow of a doubt that that is the correct solution.
Equations can be true, false, or open. If an equation is true, that means in its most simplest form, the left side of the equal sign is equivalent to the right side of the equal sign. False would be if the two sides of the equal sign are not equal, meaning that that is a false statement. That equation is not true because the left side does not equal the right side. If it's open, that means that there is a variable there. When you simplify it as much as you can, you get x or w or y is equal to, and then another value. So let's look at these examples. For example A, 85 plus negative 10. Well, 85 plus negative 10 is 75. And when I look at that, 75 does not equal 95. Therefore, this is a false equation. It's false because the left side, 85 plus negative 10, does not equal 95. On the second one, on B, 5x plus 7 equals 17. I can tell since there is one variable, that variable is already on that one side, that it's going to be open. And just from what you can remember from last year of solving equations, if I subtract 7 from both sides, that cancels. 5x equals 10. And then divide both sides by 2, x equals 5. Since it has that variable, since it does not equal, a number equal to another number, it is open. It's considered an open equation. And think about it being like open for discussion. It's open to be solved. Now on these, we're going to be looking to see, are these numbers a solution to the equation? In practice C, 8x plus 5 equals 29, and then that semicolon means, is that true for 3? Is 3 a solution? Remember, the definition of a solution is the value of the variable that makes the equation true. Think about the last slide of a true equation, both sides being equal. So to check to see if that makes it true, what you do is you check it, and this is what you will do whenever you're solving equations next chapter. You get a value that you think x is equal to, and what you do is you substitute it back in. So we're going to take 3, put it in for x, and see if this works. Now ideally you could do this in your head, but I'm actually going to write it out for the sake of teaching it to you. 8 times 3 plus 5 equals 29, and we don't really know for sure if this is a solution. I'm going to put a question mark there just to show that we are checking to see if that truly is equal. So multiply first. I'm going to have 24 plus 5 equals 29. And yes, 29 does equal 29. So yes, 3 is a solution to that equation. Let's take a look at the next one. 7 plus 16y equals 11. Let's see if that's true for 1/4. So we're going to take 1/4 and put it in for y. 7 plus 16 times 1/4. Let's see if that equals 11. Now don't stress yourself out saying, oh, I forgot what to do with fractions. Well, 16 times 1/4, remember the word of means multiply. What is 1/4 of 16? If you divide 16 by 4, you get 4. If you split 16 into 4 equal parts. Or if you actually did multiply fractions, 16 over 1, 16 times 1 is 16, 1 times 4 is 4, 16 divided by 4 is 4. So 7 plus 4 equals 11. 11 does equal 11, so yes, this is a solution. Now finally, I want you to try and find these solutions in your head. These are baby equations. Next chapter we'll get into bigger equations that I don't want you to do in your head. But just to kind of exercise your brain, think about these. What could y be? So what you're asking yourself is what's something that y could be so that when I subtract it from 7, I get 4. And so what's probably going on in your head is, so like kind of think of in a thought bubble. Let's say I want to guess, let's say 3 comes to mind. And you're thinking 7 and 4, 3, okay, there's subtraction. If I were to check that, 4 equals 7 minus 3. 4 equals 4, and that is true. So therefore, y does equal 3, and we checked that there. Now, like I said, this is going in your head. Let's say that in your mind you added because you're thinking, oh, I'm going to undo subtraction by adding. And so 7 plus 4 is 11. If I were to put 11 in here, 7 minus 11 is negative 4, not positive 4. The variable is what's happening, so you're not really undoing what's happening to the variable. That's why it's important to check these in your head. M divided by 3 equals 4. So in my head, I'm thinking, what divided by 3 gives me 4? So I'm going to, you probably already know I'm going to multiply both sides by 3, and I'm thinking the solution is 12. Well, let's say that you didn't think of 12 initially. You thought division, 4 divided by 3, you get 1 1/3, and you're like, ooh, that doesn't seem right, because 1 1/3 divided by 3 is definitely not 4. The idea with this is doing these in your head is you take something you guess, you check it in your head, and you see, does that make a true equation? So we thought about 12 though, so if I put 12 in there, 12 divided by 3 is 4, 12 divided by 3, 4 equals 4, so therefore M equals 12. You're wanting to know the solution, but the idea is you're doing these in your head.